Hello, Assalamu alaikum. I am Aliba Sadnim Mahmood. I have recently graduated from the Department of EEE BUET. Today, I will discuss phasor representation of sinusoidal waveforms, which is a topic from CAC 250 course at BRAC University. So, starting with the general expression for sinusoidal waveforms, which looks like this. Here, omega is the angular frequency and AM is the peak amplitude of oscillation. In AC circuits, electrical quantities like voltage and current may have waveforms which look like these sinusoids. Now, depending on whether the sinusoid crosses the horizontal axis with a positive slope before or after the 0-degree point, the phase shift will be minus theta or plus theta respectively. Now, if you look at this animation here, sinusoidal waveforms can be generated from a rotating vector like this, which is rotating in the anticlockwise direction. The instantaneous values for the sinusoid comes from the projection of the vector onto the y-axis. Now, if you look at the step-by-step diagram of how the sinusoid is actually created from the rotating vector, you'll see that this angle alpha is the angle the rotating vector creates with the positive x-axis, which is usually called the real axis. Now, this angle and this angle are equivalent. As the angle alpha increases, the sinusoid keeps traveling in this positive x direction. For alpha equals 180 degrees, we get half cycle, and alpha keeps on increasing and the sinusoid keeps on traveling. And for a full 360-degree rotation, we get a full wavelength of the sinusoidal wave in time period t. Now, moving on, this actually gives us the idea for phasor representation of sinusoidal waveforms. Now, why do we even do it? We do it because in sinusoidal form, the calculation for AC circuit, it gets a bit difficult since it has this kind of form. So we take it to the phasor domain or in the vector domain like this. It helps us in calculation by letting us to do the calculations vectorically. All the laws that apply for vectors apply here. So for a sinusoid like this, the vector representation looks like this. Here we show it in the complex plane where x-axis is the real axis and y-axis is the imaginary axis. Here, phasor is actually short for phase vector. It is a radius vector that has a constant magnitude, which is equal to the peak of the sinusoid here. And theta angle is created with the real axis, and it indicates the phase shift here. In some notations, instead of using the peak value, the RMS value, which is Vm by root 2, is used. But in our discussion, I am sticking with this presentation with peak value. Now here you can see two phasors rotating with the same angular frequency in the same direction, which is the anticlockwise direction. But here, there is a constant phase difference between them. To find the phase difference, we can draw a phasor diagram like this. From the phase difference, we get the phasor relationship between them. A phasor diagram can have more than two phasors, but here for simplicity, we are discussing with only two. So say this yellow vector or phasor here is V1 and the blue one is V2. Say V1 creates an angle alpha with the real axis and V2 creates the angle beta. So we say V2 leads V1. So why do we say that? It's because this anti-clockwise direction is actually the leading direction and the clockwise direction is the lagging direction. It is also evident from this sinusoid here that the V1 peak is after the peak of V2. So now how much is the leading angle that the V2 leads from V1. It is basically the angular difference, which is beta minus alpha in this case. So we can say V2 leads V1 by beta minus alpha angle. And similarly, we can also say V1 lags V2 by the same angle. So here we'll see an example. We will try to draw the phasor notation of these two sinusoids. So for the first one, we'll draw a vector here, which creates 60 degrees with the real axis. The magnitude here will be 15. And for the second one, it will create an angle 20 degrees. Since here it is a negative angle here, so it will create the angle in the clockwise direction. And this amplitude will be 10. Now, what will be the phasor relationship between them? So since I is in the leading direction, we will say I leads V by 60 plus 20 degrees, which is 80 degrees. Similarly, we can also say V lags I by the same angle. So that's all for today. Thank you very much. If you have any queries, please feel free to ask.